The next section in lesson 2.2 concentrates on end behavior. They really focus on, they dub this the leading term test. The leading term test is something that we've done all along. We want to find the leading term. That's the term that has the highest exponent on your variable, and then we want to use the leading coefficient to help us figure out whether it's going to open upward or downward. So they've got some descriptions there. I'm going to go right to a couple of examples and try to keep this as short as possible. The guided practice, here's our first example. The leading term is basically the term with the greatest power. Here it is, 4x to the fifth. What we do is we look at our power. If it's a fifth degree means our highest power is a 5. Anytime this power is odd, we've said from the previous lesson that if it's an odd power, the end behavior will be opposite. So we already know our end behavior is opposite. We should know what a fifth degree polynomial looks like. Because it is odd, it will have the S shape in the graph. So regardless of what this entire graph looks like, I know that if I just look at this term only, it's a fifth degree. It'll be S shape, a little flattered by the origin, a little steeper outside, +1, -1. And because it's a +4, this is the other thing that you get from your leading coefficient. Not only do you want to know the power, because if it's an odd power, you're going to have opposite end behavior, and it'll be this S shape that I just graphed. The other thing is, if it's a positive number, it's always going to go from low to high. If it was a negative leading coefficient, if this 4 was negative, then it would start high and finish low. And I know that we've done this several times in class, but I'm just reiterating that fact. So because of this, what I can do very quickly with end behavior is, as soon as I spot this, I know it's an S shape going from low to high because it's a positive exponent. So as x approaches a positive infinity, y's approach a positive infinity. Now when they do this, they want us to start using some limit terminology in symbols. So the limit as x approaches a positive infinity is positive infinity. It equals a positive infinity. Then they want us to use this same limit idea, but on the other side, if we go x is approaching a negative infinity, then y approaches, it's falling and getting more and more negative, a negative infinity. So if we use this limit concept for this one, we would say that the limit as x approaches a negative infinity equals it approaches a negative infinity. So this is what they're asking us to do with this end behavior. So end behavior, as soon as I know it's odd, I know that the end behavior has to be opposite. One's got to be positive infinity, one's going to be the negative infinity on these. It's just a matter of whether it goes high to low or low to high. So we're going to really focus on that leading term test. That's what they're naming it. Secondly, if I apply the leading term test on this one, typically you're going to find the leading term as the first number in your polynomial, but don't always look at just the first. Sometimes they rewrite them in a different order. They don't put them in standard polynomial form. So really search up and down your polynomial here and make sure that your first one does have the highest power. It does. Because it's an even power, as soon as I see that this exponent is even, I know that it's going to be a U-shape. If it's going to be U-shaped, it's going to have the same end behavior. And if it has the same end behavior, that's going to be pretty easy to decipher if it's going to be going towards positive or negative infinity. So we're also going to look at this leading coefficient. If it's negative, well, just like on your parabolas, if it was a negative x squared, it frowned. If it was a positive x squared, it smiles. We're just going to put this into a bigger scope with more polynomials. A sixth degree polynomial is still U-shaped. Because it's negative, it's going to be a frowning U-shape. So in general, I know in the back of my mind I got this image or the picture of a frowning graph that's a little bit tighter inside 0 and 0. It still crosses at 0, but at 1 and -1, in between here, it's pretty tight, it's pretty flat, and then it's pretty steep outside of -1, and it's pretty steep outside of +1. This is the shape I'm thinking of. That helps me figure out the end behavior. So, as the limit of x approaches a positive infinity, well, that equals, well, as x approaches a positive infinity, the y's are going towards negative infinity. And the other way that we symbolize this using the concept of limits is x approaches a negative infinity, then that limit approaches a negative infinity as well. Even when we go to the left, the y's are falling, negative infinity. If you wanted to, you could combine these two statements into one. You could say the limit as x approaches either a positive or negative infinity, you got one output, and that is approaching negative infinity. So this statement replaces that statement. End behavior. It's either going to be the same or it's going to be the opposite. Even is going to have the same end behavior. If it's negative, it's going to go towards negative infinity. If it's a positive leading coefficient, and this one was not, but if it was, you would have it approaching a positive infinity because it'd be smiling and then going towards positive. And then the odd ones are always opposite. That's kind of nice. Odd is opposite end behavior, so positive and negative. All right, that's the skinny on that topic.